Problem 2, for I equals the square root of negative 1, what is the sum of 7 plus 3i and negative 8 plus 9i? And basically, for a lot of these imaginary number questions, you just treat the I like you would treat an x. Here I would have 7 plus 3i, and then plus a negative is minus 8, plus 9i, and here I would have 7 minus 8 is negative 1, 3i and 9i is 12i. When you do imaginary number questions, you want to make sure you write your number in what they call a plus bi form, and all that means is the term with the I is written second. So here negative 1 plus 12i, or answer choice A. Problem number 11, which of the following complex numbers is equal to 3 minus 5i over 8 plus 2i? And again, this I stands for the square root of negative 1. Well, you're not allowed to have a radical in the denominator of a fraction. So what we're going to do is we're going to multiply by the conjugate of the denominator. The conjugate is basically just the denominator term with the opposite middle sign. So here, since we have 8 plus 2i, I'm going to multiply both the top and the bottom by 8 minus 2i. Now what that's going to do is the goal is to get rid of the I in the denominator. So up top we're going to have 3 minus 5i times 8 minus 2i. On the bottom we're going to have 8 plus 2i times 8 minus 2i. So we're going to have to do some foiling both to the top and the bottom. I'm going to start off looking at the denominator and specifically what happens when you FOIL conjugates together. Here your firsts, 8 times 8, is just going to give you a 64. But now your outsides, 8 times negative 2i, that's negative 16i. The insides, 2i times 8 is positive 16i. When you multiply conjugates together, the outers and the inners, the oi, cancels. So here you're just going to have to do your firsts and then your lasts. Positive 2i times negative 2i is negative 4i squared. So here on the denominator, we'll get to our numerator in a second, we have the 64, the outers and inners are gone, minus 4i squared. And here, since I is equal to radical negative 1, I squared is just radical negative 1 times radical negative 1, and when you multiply two radicals together, you're left with just the radicand, which in this case is negative 1. So I squared is the same as negative 1. So this is going to be 64 minus 4 times I squared, but I squared is negative 1. So that's going to be 64, and then negative 4 times negative 1 is a positive 4. So that's going to leave me with, in my denominator, 68. So the goal was to get rid of the I in the denominator. Now let's take a look at our numerator. Here, the numerator, we're going to have to do the full FOIL because we're not multiplying conjugates. The first, 3 times 8 gives you 24. The outsides, positive 3 times negative 2i is negative 6i. The insides are negative 5i times positive 8, so that's going to be negative 40i. And then here the lasts, negative 5i times negative 2i is positive 10i squared. So here I'm going to have 24, and then negative 6i and negative 40i gives you negative 46i. But I squared, we said before, was just negative 1. So here you have positive 10 times negative 1, or a negative 10. And this is all over 68. And then I have 24, take away 10 is 14. So I have 14 minus 46i over 68. I'll now divide the denominator into both parts up top. So here I'm going to have 14 over 68 minus 46i over 68. And then I'll start dividing by 2. 2 goes into 14 7 times. 2 goes into 68 34 times. So I have 7 over 34 minus 2 into 46 is 3 times. 2 into 68 is 34 times. So 23 over 34, and then don't leave off the I. So here's my answer. 7/34 minus 23 over 34ths I, or answer choice C. Problem 14, if this expression is written in the form a plus bi, remember anytime you have imaginary numbers, you have to write the imaginary part second. So if your answer is written in a plus bi form, the question says, what is the value of a? Well, here again, we're going to have to rationalize the denominator. I'm going to multiply both the top and the bottom by the conjugate. Remember, the conjugate is just your denominator with the opposite sign. So here, since you have 3 minus 2i, I'm going to multiply both the top and the bottom by 3 plus 2i. So when you multiply conjugates, as we saw in the last question, the outers and inners will just cancel. So all you really have to do is multiply the firsts, 3 times 3, so that's going to give you a 9. And the lasts, negative 2i times positive 2i, is a negative 4i squared. Remember that I squared is always equal to negative 1. So here we're going to have 9 minus 4 times negative 1, or 9. And then a negative times a negative in math is a positive, so I have 9 plus 4, or 13. So my denominator is 13. Now for my numerators, I'm going to have to fully FOIL 8 minus I times 3 plus 2i. These are not conjugates, so I've got to do the full FOIL. The firsts, 8 times 3, that's 24. The outsides, 8 times 2i, that's 16i. The insides, negative I times positive 3, or negative 3i. And then the last, negative I times positive 2i, is negative 2i squared. So up top, we're going to have this 24. And then 16i minus 3i is 13i. And then negative 2 times I squared, well, I squared is just negative 1. So negative 2 times negative 1 is positive 2. So here my numerator, 24 plus 2 is 26 plus 13i. And then I'll take my denominator of 13 and divide it into both parts. So it's 26 over 13 plus 13i over 13. And then 13 goes into 26 2 times, so I have 2 plus, and 13 over 13 is I. So here my answer is 2 plus I, but the question says if this is written in a plus bi form, what is the value of a? Well, in this case, a is going to be answer choice A of 2. If the question said what is b, what is the coefficient of I, here b would have been positive 1. But here my answer is letter A. Problem 19, these are again rationalizing the denominator. Here I'm going to multiply both the top and the bottom by 5 plus 3i, because that's the conjugate of 5 minus 3i. When you multiply conjugates, the outers and the inners will always cancel, so all you have to do is multiply the firsts, 5 times 5, to get 25. And the lasts, negative 3i and positive 3i, is negative 9i squared. Always remember that I squared is negative 1. So I have negative 9 times negative 1, or positive 9. So here my denominator is 25 plus 9, or 34. Now this one's different from the last in that my numerator, I don't have to FOIL. Here I'm just going to take the 2 and distribute it to the 5 and the 3i. So 2 times 5 is 10, 2 times 3i is 6i. So here I'm going to take my denominator of 34 and divide it into both parts up top. So here I'm going to have 10 over 34 plus 6i over 34. And then 2 goes into 10 5 times, into 34 17 times, so I get 5/17, plus 2 into 6 is 3 times, 2 into 34 is 7 times, so 3i over 17, or 3/17 I. So that's why my answer is letter C. Problem 20, 8i over 4 plus 9i. I'm going to rationalize the denominator by multiplying the top and the bottom by the conjugate of the denominator, so the opposite sign, 4 minus 9i. For conjugates, all I have to do is the first and the last, so the firsts, 4 times 4, that gives you a 16. The lasts, 9i times negative 9i is negative 81i squared. Always remember that I squared is negative 1. So here I have 16 minus 81 times negative 1, or 16, and then negative and negative is a positive 81. So that's going to give me 97 as my denominator. My numerator, I'm just going to take the 8i and distribute it to the conjugate, distribute it to the 4 minus 9i. So that's going to give me 8i times 4, or 32i. 8i times negative 9i is negative 72i squared. Remember, I squared is negative 1, so negative 72 times negative 1 is positive 72. So here I have 32i plus 72. Remember though, with imaginary numbers, you always want to write it in a plus bi form. You want to have your imaginary term second. So my numerator, I'm just going to kind of switch places. Here my numerator, I'm going to write that as 72 plus 32i. Here my denominator is 97. And what I'll do is I'll take my 97 now and set it up over both parts of the numerator. So 72 over 97 plus 32i over 97, or answer choice C. Problem 21. This one's a little bit different. I'm still going to quote-unquote rationalize the denominator, but here, since I is equal to the square root of negative 1, I'm going to multiply both the top and the bottom by I. I want to make the i's disappear in my denominator. If you had, for example, 3 over radical 2, you'd multiply both the top and the bottom by radical 2 to make the denominator turn out to not have a radical in it. Well, same difference here, except I'm not multiplying by radical 2. I'm going to multiply by radical negative 1, which is just I. So what happens is my denominator becomes negative 6i times I is negative 6i squared. But remember that I squared is equal to negative 1, so it's negative 6 times negative 1, or positive 6. Here my numerator, I'm going to distribute the I to both terms. So I times negative 4 is negative 4i. I times 8i is 8i squared. But again, since I squared is negative 1, I'm going to have 8 times negative 1, or negative 8. So negative 4i minus 8 over 6. Remember, with imaginary numbers, you always want to have the I term second. So here I'm going to switch the negative 8 and the negative 4i. So here I have negative 8 minus 4i over 6. I'll now take the 6 and divide it into both parts up top. So I have negative 8 over 6 minus 4i over 6. And now I'll simplify. 2 goes into 8 4 times. 2 goes into 6 3 times. So it's negative 4 thirds. 2 goes into 4 2 times. 2 goes into 6 3 times. So minus 2 thirds I. So here my answer is letter D, negative 4 thirds minus 2 thirds I. Problem 24. Which of the following is the equation of a circle? Remember, the equation of a circle is x minus h squared plus y minus k squared equals r squared, when h comma k is the center of the circle and r stands for the radius. So here, which of the following is the equation of the circle if the center is 0, 4? So that's good. So they're telling me the h and the k is 0, 4. And they're telling you not what the radius is equal to, but a radius with an endpoint. So here's what we have going on. We have the center of the circle at 0, 4, and then a radius of the circle is at 4/3, 5. Now 4/3 is the same as 1 1/3. So that's going to be 1 and a little bit more, and then up to 5. So basically, we're going to have a circle whose center is at 0, 4, and whose radius has an endpoint of 4/3, 5. Well, what I can do is I can find the length of the radius by finding the length of this line segment. If I know the center is at 0, 4, and I know the radius has an endpoint of 4/3, 5, so I have 0, 4 and 4/3, 5. What I can do to figure out the length of this radius is I can use the distance formula to figure out the distance between those 2 points. Because if I can figure that out, that's going to be the radius of the circle. So here the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember, what you do is you call one point x1, y1, and you call the other point x2, y2. It doesn't matter which is which. So here I'll call my center x1, y1. So here x1 is 0, y1 is 4. And then x2, y2 will be 4/3, 5. So here x2 will be 4/3, and y2 will be 5. So I'm going to plug these values into the distance formula to get the distance between those 2 points, and then once I know that, that's going to give me r, the radius of the circle. So here I'm going to have the distance equals the square root of x2 minus x1. So in this case, 4/3 minus 0 squared plus y2 minus y1, or 5 minus 4 squared. So here the distance, the length of the radius, is going to be 4/3 minus 0 is 4/3 squared, it's the square root, plus 5 minus 4 is 1 squared. So here if I do this on my calculator, here I'm going to have, so here it looks like the distance is going to be 5/3. So that means our r is going to be 5/3. So now I'm going to plug that in for the radius. So here I know the center of the circle is 0, 4. I know the radius is 5/3. So I'm going to plug into this circle formula. Here I'm going to be left with, I have x minus h squared. So I'll write out the formula. X minus h squared plus y minus k squared. That's going to be equal to r squared. But here I said h was 0, so x minus 0 squared is just x squared, plus y minus k. Well, that's going to be y minus 4 squared. Normally you would think you have to FOIL that out, but for the equation of the circle we can kind of keep that as is. And here I know the radius is 5/3. So here it's going to be 5/3 squared, or 5/3 times 5/3, or 25/9. So here is the equation of the circle. The equation of the circle is x squared plus y minus 4 squared equals 25/9, or answer choice A. Problem 24. The equation of the circle in the xy plane shown above is this equation. And the question is, what is the radius of the circle? Well, here's what we want to do. The equation of a circle is x minus h squared plus y minus k squared equals r squared. So somehow I want to take this equation and algebraically turn it into that. And the way I'm going to do that is a process called completing the square. What I'm going to do is I'm going to group together my x's and my y's. So here I'm going to have x squared plus 4x, and then I'm going to have y squared minus 2y. And then I have negative 1. I'm going to complete the square. I'm going to cut the 4 in half to get 2. I'm going to cut the negative 2 in half to get negative 1. Now, why am I doing this? I'm trying to turn this into this equation. How do I get the x minus h and the y minus k squared? You complete the square. So you cut the coefficients of the variables in half. You square those. So 2 squared is 4. Negative 1 squared is 1. So here I'm going to add 4 and 1 to that left-hand side of the equation. But in order to keep the equation true, to keep it balanced, I'm going to have to add 4 and 1 to the right-hand side. Now, why is this taking place? Well, here's what's going to happen. If I go about factoring my x's, if I factor x squared plus 4x plus 4, that's going to factor into x plus 2 times x plus 2, or x plus 2 squared. You see how this plus 2 appeared here. Why did that appear? Because I did this process of completing the square. So my x's are just x plus 2 squared, which is good, because you see the equation of the circle is x minus h squared. Now I know what my h is. And same difference here. My y's can be factored into y minus 1 times y minus 1. That's how this would factor, or y minus 1 squared. So here I have, if I kind of compare it to the general form of a circle, x minus h squared plus y minus k squared, now I have that form. I know h is going to be negative 2, because x minus negative 2 is the same as x plus 2. So I know h is negative 2, and I know k is positive 1. But this question didn't say that. The question said, what is the radius of the circle? Well, here, that's this r squared. So what do I have for r squared? Here I have negative 1 plus 4 plus 1, or the negative 1 and the positive 1 cancel, 4. So here I'm going to have 4 is equal to r squared, or r is going to be equal to the square root of 4, or 2. So in this case, the radius of the circle, r, is going to be equal to 2, or answer choice A.